Page 301, question number 5. When a spring is stretched by 0.400 meters from its equilibrium position, its elastic potential energy is 500 joules. So we have an x value of 0.400 meters, and we have an energy of 500 joules. Part A, what is the magnitude of force required to produce this amount of stretch? So we know force is equal to K times X, the spring constant times the amount of stretch. Problem is we don't have our K value, but we do have the energy. So we know that the energy is equal to Kx squared divided by 2. So rearranging this for K will give us a K value. So K equals 2 times the energy divided by X squared. So we have 2 times 500 joules divided by 0.4 meters squared. Plug that into the calculator. 2 times 500 divided by 0.4 squared, and that gives us a K value of 6,250 newtons per meter for the spring. Now that we know that, we can figure out our force. So our K value is 6,250 newtons per meter times 0.400 meters gives us a value of 2,500 newtons, or 2.50 times 10 to the power of 3 newtons with 3 significant digits. That leads into part C. If the force causing the stretch is changed to 1,000 newtons, how much change in elastic potential energy results? So now that we have a force, we need to find our stretch. So F equals Kx. We know the force is 1,000 newtons. We know our K value is 6,250 newtons per meter. We're looking for X. So X will be F over K, 1,000 newtons divided by 6,250 newtons per meter gives us stretch of 0.16 meters, and we are looking for the energy. So our change in energy will be our Kx squared divided by 2 minus Kx initial squared divided by 2. This is X final. So factoring this, we're going to get K over 2 X final squared minus X initial squared. So 6,250 newtons per meter, should be 5, divided by 2, our final stretch is 0.16 squared minus our initial stretch, 0.400 meters, or 0.4 meters squared, close brackets. We should get a negative value because we are decreasing the amount of stretch, so we are releasing spring energy from the system. So 6,250 divided by 2 times brackets 0.16 squared minus 0.4 squared equals negative 420 joules. So again, the system is losing 420 joules because it's being released. The spring is not being stretched as much as it was previously.